Hello everyone, welcome back to our channel. And as we said, today we are going to tackle about the Krebs cycle. So in the previous video, we had a video about glycolysis, and today I saw it wise for us to complete the Krebs cycle so that we can complete the metabolic pathway. So basically, Krebs cycle is just like glycolysis, and it's just as simple as glycolysis. And today I'm going to teach you some simple ways in which you can understand the Krebs cycle. So here is a formula before we start, and the formula is so here is the formula that we are going to learn today. And the formula goes: can Adam inspire a super smart funny man? Can Adam inspire a super smart funny man? And the first C stands for citrate. That's the first C, stands for citrate. And this A stands for the enzyme that facilitates the formation of citrate, that is called aconitase. So this I facilitates, this I is called isocitrate, and this So this I stands for isocitrate, this A stands for alpha ketoglutarate, and this A stands for succinyl coenzyme A, and this S stands for succinate, and this F stands for fumarate, this M stands for malate. So this is the simple formula that will help you understand and analyze the Krebs cycle. So just as we learned from the previous lesson, that the final byproduct of glycolysis was pyruvate. So we are going to use this pyruvate to come up with this Krebs cycle. So this pyruvate, and I'm going to draw a cycle here. Just going to draw a cycle here, and the cycle starts with pyruvate. So as we said in the previous video, and for those who are surprised where this pyruvate comes from, said this glucose and undergoes glycolysis to yield pyruvate. So for those who are surprised where the pyruvate comes from, you can visit our previous video. It is in our YouTube channel, NSU Academy. You can go check the process just as we explained. So this pyruvate, the enzyme that facilitates, it's called pyruvate dehydrogenase. So the enzyme that facilitates here is called pyruvate dehydrogenase to form acetyl coenzyme A. So this acetyl coenzyme is what goes into the Krebs cycle. So acetyl coenzyme A is a 2-carbon molecule, and I'm just going to draw a cycle so that we may understand the Krebs cycle. So we are going to start with the oxaloacetate. Oxaloacetate is a 4-carbon molecule and comes to citrate, comes to isocitrate, goes to alpha ketoglutarate, succinyl succinate, goes to malate, then it goes to the oxaloacetate. So just as we said, this acetyl coenzyme A, this is the acetyl coenzyme A. So basically, from glucose to pyruvate is the glycolysis process, and pyruvate is converted to acetyl coenzyme A by pyruvate dehydrogenase. And whenever we hear the term dehydrogenase, what comes into our mind is NADA positive is converted to NADH. So this is what comes into our mind whenever we hear the term dehydrogenase. So oxaloacetate is a 4-carbon molecule, combines with acetyl coenzyme A, a 2-carbon molecule, to form a 6-carbon molecule called citrate. And we are going to look in each steps. It has the 8 steps, and in each step we are going to look at the enzyme that facilitates the process. So oxaloacetate, when it combines with acetyl coenzyme A, the enzyme that facilitates the process is called the citrate synthase. And from citrate to isocitrate, it's called aconitase. This is the enzyme. And from isocitrate to alpha ketoglutarate is called the isocitrate dehydrogenase that facilitates isocitrate to alpha ketoglutarate, we say is the isocitrate dehydrogenase. And from alpha ketoglutarate to succinyl coenzyme A, we said is the alpha ketoglutarate dehydrogenase. From alpha ketoglutarate to succinyl coenzyme A, CoA, is the alpha ketoglutarate dehydrogenase. From succinyl to succinate is the succinyl CoA synthetase. From succinate to succinate is the succinyl CoA synthetase. From succinate to fumarate is the succinate dehydrogenase. From fumarate to malate is called the fumarase. And from malate to oxaloacetate is called the malate dehydrogenase. And this the overview of the enzyme. Just as we said, the first this is the overview of the enzyme. And something I want us to learn that will help us in quick analysis of the Krebs cycle. Whenever we hear of the term dehydrogenase, what should come into our mind is that NAD positive is converted to NADH. And from isocitrate to alpha ketoglutarate, we have isocitrate dehydrogenase. So whenever you hear of the term dehydrogenase, what should come into your mind is that NAD is converted to NADH. And this is the first step, that NAD positive is converted to NADH. And from alpha ketoglutarate to succinyl CoA, we have the alpha ketoglutarate dehydrogenase. So what should also come into your mind is the same thing. NAD positive is converted to NADH. And from succinate to fumarate, we have the succinate dehydrogenase. This is somehow different, but it's the same concept. FAD is converted to FADH2. And from fumarate to malate, we have the fumarase. From malate to oxaloacetate, we have the malate dehydrogenase. And what should come into your mind is NAD positive is converted into NADH. So just an overview from the previous process, which was glycolysis. We said that two molecules of pyruvate are formed. And the theory behind these two molecules of pyruvate, we said the dihydroxyacetone phosphate is converted into acetyl, is converted into glycealdehyde 3 phosphate. So for those who want to understand more of where the two pyruvate comes from, you should review from the previous process. So we said two molecules of pyruvate are formed, meaning that in this process 2 NADH will be formed, 2 and here 2 NADH will be formed. And something we should also understand, from isocitrate to alpha ketoglutarate, decarboxylation occurs and CO2 is given out. And from alpha ketoglutarate to succinyl-CoA, decarboxylation occurs and CO2 is given out. And from succinyl-CoA to succinate, from alpha ketoglutarate to succinyl-CoA, decarboxylation also occurs and carbon dioxide is given out. And from succinyl-CoA to succinate, there is something here that occurs which is called oxidative phosphorylation that gives ATP. So in this process, what we should understand, we said 2 NADH are formed here, plus these two gives 6. These are the products. Gives 6 NADH, and we have 2 and 2 here, which gives 4 carbon dioxide, and we also have an ATP here, 2 ATP. We have FAD is converted to FADH from succinate to fumarate. So the enzyme that facilitates this process is called the succinate dehydrogenase. And we said whenever you hear the term dehydrogenase, just know either an NAD is converted into NADH or a FAD is converted into FADH. So here also we have 2. So 2FADH2. So these are the products of Krebs cycle. So an overview of what we learned for you to understand more. We said that this is the formula that can aid in your understanding, and the formula goes: can Adam inspire a super smart funny man? And this citrate, when it combines with oxaloacetate, just as we showed here, it gives citrate. No, when acetyl enzyme A combines with oxaloacetate. So when acetyl coenzyme A combines with oxaloacetate, they give citrate, and this is denoted by can, citrate. Adam, this is for aconitase, the enzyme that facilitates citrate to isocitrate. And inspire stands for isocitrate. A stands for alpha ketoglutarate, just as we said here. And S stands for succinyl-CoA. The second S stands for succinate. And F stands for fumarate. M stands for malate. So this will help you or aid your understanding in this process. So what you need to understand is that in the process we have this dehydrogenase, isocitrate dehydrogenase enzyme, alpha ketoglutarate dehydrogenase enzyme, and succinate dehydrogenase enzyme, and malate dehydrogenase enzyme. So if you understand or if you understand this alpha ketoglutarate dehydrogenase, you automatically remember what we said, that NAD positive is converted into NADH. So that will aid in your understanding. So what I can just tell us is that go and analyze where does this dehydrogenase or which enzyme facilitates the process, and this formula will help you in understanding the products formed, and you just go and analyze the enzyme that facilitates each process, and from the enzyme you'll automatically come up with the products that are formed. So thank you for watching this process, the Krebs cycle, and follow for more at NSU Academy. We appreciate your subscription and your continuous support. So thanks for following, subscribe and share to your friends. Thank you. About the Krebs cycle, kindly write your comments on the chat message and let us understand where is the problem. I will kindly share the notes for those who will love to understand the process. Thank you.